This lesson is going to be going over finding the percent. So when we think about the percent, we want to remember our relationship, which is that a percent is just a part to whole ratio, but that whole is going to be set to 100 because the percent is for every 100. So in these problems, we're going to be given the part and the whole, and we're going to be looking for what is my percent. So an example of this would be Mr. 40 ate 40 of the 62 cookies I baked. What percentage of my cookies did he eat? So going back to my percent relationship, this is saying that I had 62, so that's going to be my whole. Mr. 40 ate part of them, he ate 40. So that'll be my part, and what I'm looking for is what percent will I have, or what percent does that represent? And we remember that percent is the number relationship for every 100. So using a ratio table to understand this relationship, we know that 62 will be my 100% because it's my whole. And I'm looking for what percent will 40 be of my 62. So to solve this, I'm going to work on getting my unit rate. And then from my unit rate, I know I can get to any number. So starting to get 62 to 1, I have to divide both sides by 62, or multiply both sides by 1 over 62. And 100 divided by 62, we can just write as 100 over 62. And now I want to get to 40. So multiplying both sides by 40, I would get 100 over 62 times 40, or 62 and 5/10. So this would tell me that Mr. 40 ate 62 and 5/10% of my cookies. Now thinking about this as a general rule, I'm going to start off by drawing a diagram. When looking for a percent, we'll always be given the part and whole, so it'll look something like this in general. We'll have the whole and the part, which the whole is equal to 100, and we're looking for this percent. Now if we look at what we did over here, we started off with the whole and it's set equal to 100, and we found the unit rate of the quantity. So we found out what was 1. But to do this, we had to divide the 100% by the whole, because we're trying to get that whole to become 1. So the whole divided by the whole will equal 1. Same thing here. So we take 62 and we multiply by 1 over 62 to get 1 here. Whole times 1 over the whole. So then we have to also do that to 100. 100 times 1 over the whole. So I'm just drawing that here, that 1 is going to be equivalent to 1 divided by the whole. And then from there, we're going to go from our unit rate of our quantity, and we're going to multiply it by whatever that part is that we're looking for the equivalent percent. So now I'm going to take this 1, and I'm going to multiply it by the part. Same thing up here, I would multiply it by the part. And so I would find the unknown percent by putting all of those numbers together, just like I did up here. And when I do that, I see that the percent can be found by taking 100 and dividing it by the whole and multiplying it by the part. So this will be the first method, that we can find the percent by taking 100 divided by the whole times the part. Now to find the second method, what I'm actually going to do is I'm just going to rearrange this. So if we think about, remember that we said when we divide by a number, it's the same thing as multiplying it by 1 over that number. So if I look at this part right here, I can rewrite this as 100 times 1 over the whole times the part. Now we know that with multiplication, it has a commutative property, which means that I can move the parts around, right? We know that if I have a number, let's just come over here. If I have 2 times 3, that's the same thing as 3 times 2. So I'm just going to move these around. And I could also say that this would be the same thing as if I took the part times 1 over the whole times 100. So here I've just highlighted it so you can just see. The only thing I've done is I've just switched my 100 and my part, and I can do that because of the commutative property that says that, for instance, if I have 2 times 3, it's the same thing as 3 times 2. So now I'm just going to regroup those. So this would be the same thing as the part times 1 over the whole, or the part divided by the whole times 100. And so this is another way that we can think of finding the percent. And either of these work. Now I want to try to make sense of why this equation actually makes sense. If we look at the definition of percent, this is actually the definition here. So the percent is equal to the part to whole relationship, but it's for every 100. And so actually when we look at like what you would see maybe when you go into a regular math textbook, this second method is what you'll usually see. But it's good to know and important to know that we can calculate it either ways, because when we're doing mental math, sometimes one way is easier than the other. Let's look at a real quick example, first of all, to see how to use both formulas, but also to see how it can be useful to decide which one you're going to use. So in this, it says, what percent is 40 out of 50? So 40 will be my part and 50 will be my whole. And here in both methods, I'm going to start off with this first one. This first one says that the percent is equal to 100 over the whole times the part. So if I'm looking at this problem and I'm thinking about this equation, well, then it would be 100 over my whole, which is 50, times my part, which is going to be 40. And 100 over 50 we can think of as either simplifying that as a fraction or 100 divided by 50. So that'll be 2, and then times 40 will give me 80. So I know 40 is 80%. Now using the second method, same problem, I will use part. I'll say that the percent is equal to the part over the whole times 100, or in this case, my part, which is 40, over my whole, which is 50, times 100. So now I want to think about this fraction and what I can do with it. So I'm going to take it up here for just a second so that I can think of what is 40 over 50. So I know that 40 over 50 can be simplified to 4/5. And if I want to get it into a decimal, it's helpful to get it into tenths, hundredths, or thousandths. So I'm going to say, oh, well, 5 I can get into tenths by scaling that fraction up by 2, and I would get 8 tenths. And 8 tenths as a decimal looks like 0.8, or properly named 8 tenths. So now I'm going to fill that back into my equation, and I would get 8 tenths times 100. I'll get 80. So same as the other method. 40 is 80% of 50. Now, what we want to do is we want to look at these and just compare and contrast. Think about, we got the same answer, they're about the same amount of steps, but which one was easier to calculate? Was it easier to calculate when I had 100 over the whole times the part, or the part over the whole times 100? So was it easier to think of 100 over 50 or 40 over 50? So that's kind of where, I mean, if it was me, I would think that 100 over 50, simplifying that to 2 and then just 2 times 40 would be easier than having to think about what this fraction is equivalent to. But it's all about personal choice, and those are just two methods. We want as many tools in our toolbox. So that is how we find the percent when looking at, or when given, the part and the whole.